Hi everyone, in this video we shall see how to solve simultaneous equations using the matrix method. Now let's see this example to illustrate the method. We want to solve this simultaneous equation. So the first thing we will need to do is to write this equation in the matrix notation. So we write this as 3, coefficient of x here is 3, the coefficient of y here is minus 5, and this is 1, while the coefficient of y here is 2, times xy equals, we put this also in matrix notation. Now this can be represented as A times x equals B, where A is this matrix, x is the matrix xy, and B is this. Now to solve this equation, we need to pre-multiply by A inverse. So we pre-multiply, we have A inverse times A times x equals A inverse times B. Now take note that we pre-multiplied by A inverse and not post-multiply. So A inverse times A gives us the identity matrix I times x, which is equal to A inverse times B. And I times x, the identity matrix times x, gives us x equals A inverse times B. So to solve this equation, the solution to this equation equals A inverse times B and not B times A inverse. Remember that in matrix multiplication, the order matters. So it is A inverse times B, not B times A inverse. So to solve this, we need to find A inverse. Well, A equals, remember that A is 3 minus 5, 1, 2. Now recall that to find A inverse, the inverse of a 2 by 2 identity matrix, if A equals A, B, C, D, then A inverse will be equal to 1 over the determinant of A times, we interchange the positions of A and D, so we have D, A here, and we change the signs of B and C, minus B minus C. So this gives the inverse of A, 1 over the determinant of A times this new matrix that is formed. Now to find the inverse of this, we find the determinant of A first. The determinant of A equals 3 times 2 minus 5 times 1. And this gives us 3 times 2 is 6, minus 5 times 1 is minus 5, minus times minus is plus, so, and that gives us 11. So determinant of A is 11. Now A inverse will be equal to 1 over 11, 1 over 11, we are using this formula now, times, then we interchange the positions of A and of 3 and 2. So we have 2 here, 3 here, and we change the signs of these two guys. So the sign of 5 here is negative, so it becomes positive 5. And the sign here is positive, so we change it to negative and we have minus 1. By using this, this formula, change the signs of B and C, interchange the positions of A and D. And so this gives A inverse, 1 over 11 times this. So x will be equal to A inverse times B. And that is equal to A inverse is 1 over 11, 2, 5, minus 1, 3, times B. B is the column matrix 13 and minus 3. So we multiply this two matrices. So this gives 1 over 11. So to multiply this, we multiply the first row here with this column. So we have 2 times 13 plus 5 times minus 3, and then we have minus 1 times 13 plus 3 times minus 3. And this gives 1 over 11. 2 times 13 is 26 plus 5 times minus 3 is minus 15. So we have 26 minus 15. This is a minus 13. 3 times minus 3 is minus 9. And this gives 1 over 11. 26 minus 15 is 11. And minus 13 minus 9 is minus 22. And this is equal to, so 1 over 11 times what we have here, 1 over 11 times 11 gives us 1. 1 over 11 times minus 22 gives minus 2. And this is the value of x, y. So that's our x. So it means that x equals to 1 and y equals minus 2. So the solution to this simultaneous equation using matrix method is x equals y and y equals minus 2. I hope you enjoyed this video. If you have any question, you can drop them in the comment section. Thank you.